Soil aggregates are particles in the soil that are tightly bound together, and they're more tightly bound together than they are to adjacent particles. Now what we've done is over the spring and summer is we've collected soil from many different areas on the property, and a lot of it's been focused on the north pivot and south pivot areas, and also in the crested wheat field that's just next to the orchard. And a lot of those samples we've sent out for nutrient analyses, which we can use to determine the quality of the soil and also to determine what kind of vegetation would likely be able to grow there. And an in-house quality of the soil that we're going to be looking at is aggregate stability. And we can do that here. It's a really simple method, and we can do that with a wet sieving apparatus. Aggregate stability is an important function of the soil's resistance to erosion. And water-stable aggregates are going to be more tightly bound together in the soil so that in the face of rain or other outside influences that are going to degrade the soil, they'll stand up more easily. So what we're going to do is take this information of aggregate stability, which is a good indicator of the quality of the soil and its resistance to erosion, and we're going to be examining the north pivot area, south pivot area, and kill-crested area, or the crested wheatgrass field, for an overall measure of the percent aggregate stability. And if they have a high percentage of aggregate stability, that means the soil is functional and it's more resistant to erosion. And with a lower aggregate stability, it's not as stable a quality of the soil. And then we can use that information to look at what kind of vegetation we can plant there in the future. We can use that to indicate the quality of the soil, and we can also use that to know what we have to do to increase the quality of the soil. And what I was going to do today was show you how we measure aggregate stability. So how we do that is using the wet sieving apparatus. And the idea behind this is that unstable aggregates are going to be disrupted by water. So what we do is take an original soil sample and we just dump it into one of these sieves, and then this machine gets turned on and it gets dumped into a cup of water, and what happens is the machine moves up and down and we keep those samples in there for about 5 minutes. And then after the 5 minutes is over, what we have in the sieve after the water drains out is any stable aggregates that are still bound together and any coarse material like sand and other organic materials. And so what we do with that is we take this sample and dry it in the oven, and then after about 2 days we're going to have the stable aggregates plus coarse materials, and then we can take that and have a dispersing agent, and we mix that in with the soil sample, and what that'll do is declump the stable aggregates that are bound together, and then we can take that unclumped material, wash it through this same size sieve, and dry that material, and what we'll have left over is just the coarse material that was in the original soil sample. So then in the end we can make a calculation and take this coarse material, subtract it from the original amount of soil that we had, and then we can use the amount of stable aggregates plus coarse material to get a calculation for the percentage of aggregate stability that we have in our soil. And with a measurement of percent aggregate stability, we can take that information and determine the soil quality in the north and south pivot areas and any other areas that we've sampled soil. And we can use that as a tool to determine what kind of restoration needs the soil will need to make it of a higher quality, and also what kind of vegetation we can plant into those soils.